This is a Calibrators Crystal No. 10. It was originally designed for use with the wireless set 62 to set accurate spot frequency. Very similar to a lot of other calibrators crystals of its time, but this one is quite interesting for a number of reasons. Basically, it's quite simple to use. There's only 3 settings, either off, 500 kilohertz, which gives you a crystal. It's a 500 kilohertz crystal, which gives you obviously markers 500, 1 meg, 1.5 meg, 2, etc. Up to about 10, because that was what the wireless set 62 went to. But the details on this actually say you'll find harmonics up to about 30 meg. Now the dial, it says here, there's the 3rd setting. That's the dial here. There are actually 4 little scales on there, and by adjusting this control in the middle here, it adjusts another oscillator inside between 250 and 500 kilohertz. So when you have it on this setting, it just gives 500 kilohertz and multiples thereof. When you put it on dial, you have the 500 kilohertz oscillator plus the 2nd oscillator inside, which is variable, connect to this, and that allows you to pick any frequency in between. Here's a closer view of the scale. You can see the markings on it. This is actually the circuit diagram that goes with it. A lot of my own markings on it. It consists of 4 stages basically. You have a variable oscillator with a battery valve 1T4. This is the fixed crystal oscillator, this is crystal, which is another 1T4. In the middle you have a heptode, which is an IR5, that mixes either one or both, or should I say it's either that one or both of the two. And this is an interesting little one here. This actually is a voltage regulator, which is a neon tube essentially, and they're using that as a neon relaxation oscillator to give some little blips on the output of the oscillator here, which means that when you listen to it on a receiver, you can hear by this plopping noise regularly going on in the background that it's actually coming from this device rather than heterodyning with another signal, for example. The only thing I will say about this is we have 2 of these models, and both never worked when we received them. This one's in seemingly very good condition, but there are a lot of component failures on them. So I would imagine if anybody else has a go at fixing this, one of these, they'll probably find exactly the same thing. These are in fact battery valves. They're small miniature battery valves, and they are running on a 12 volts down here, so 12 volts going through a potential divider on a pot here, and that gives the 1.4 volts for each one that they need to operate. The rest is 300 volts coming in here, and it drops down to 96. You have 50 volts on the anode of V2, for example, at the end of the day. One of the biggest problems you find with them is this oscillator. It just doesn't work. And that's a stupid comment perhaps, but the point is, some of these, once these capacitors start shifting slightly and they're a little bit leaky, the whole thing doesn't work. So I've changed most of the components in this area on both sets to actually make that thing work. Otherwise it just doesn't work. Obviously problems at the other end as well have the same sort of thing. So all in all, it's certainly not a fun thing to try and mend if you think you'll have a use for it. Not as flexible as many other crystal calibrators, you know, from the war years, but it works. This one works now. Or I should say the other one works. This one half works because we fixed some of it, and we'll show you it working. Here you see the inside of the Calibrators Crystal No. 10. 4 valves, 1, 2, 3, 4. These 2 normally are in cases, but we've taken these off so that we can actually view this one. This 4th one is, as I said, this is a voltage regulator. This is not actually a valve, and in fact the voltage regulator is in fact very similar to a neon bulb, and they're using it as a neon relaxation oscillator. Anybody unfamiliar with that? It's simply attach a couple of resistors and a capacitor, pop it across it, put a high voltage, and it will oscillate, and it gives a sawtooth waveform. You could use that sawtooth for a number of things, even a simple scope. You could use that as your X deflection. This is the capacitor, tuning capacitor we call it. This is the variable capacitor, which is used for the variable oscillator. This is the crystal here, and it's a big brown case. This is 500 kilohertz. These screws, seemingly along the bottom, in fact, are capacitors. They're 0.1 microfarad capacitors on the other side. Now, this is an awkward little fella to work with, because there's a case obviously removed to pick these up. But to do any wiring underneath here, you have to take the whole thing apart, and it's very difficult, relatively speaking, setting up the tuning afterwards from the control on the front to the capacitor here. Now what we'll do now is, if I power up the set, we're now powering it up. You can probably see we have a flash coming from the neon. If I turn off this light here, make it easy to see. So what we're looking at here is, this is the voltage regulator, which is really working as a neon bulb relaxation oscillator, and it is in fact pulsing the signal from the rest of the circuit. What we'll do now is we'll turn that off and connect it up to a receiver and see if we can make it work. In order to do this test, we're using our trusty R1155 receiver. All we'll do is we'll use a couple of frequencies on the dial. This isn't a particularly accurately calibrated one, but it's pretty close actually. I say that, but it's not spot on, that's all. We have this actually set to 5 megahertz. It's tuned to 5 megahertz, and there's nothing there. Have a lot of interference. We're connecting up through this little aerial box here, going straight through to the aerial terminal on the crystal calibrator, because that's what it has on there. It has an aerial and a ground connection here, and this is just the power in there. So with that set to 5 meg, if we now turn this on, we'll put it onto 500 kilohertz only, and hey presto, it works. Now interestingly enough, this plopping sound is not even. It appears to be the voltage regulator tube, the neon in other words in there. This one is actually our second one. Here's one we did earlier. That one is the one we were just looking at. This one is actually the one which we finished and is in good working condition. So that's it. So if we tune that in and out, there's a bit of hum coming from the fluorescent lights. That's it. So in fact, if we go up now to 5.5 meg, that's where the orange meets the blue, we pick up another 500 kilohertz signal. Go down to another one, that's 4.5, and that's 4. So it's quite a useful little set for checking your markers every 500 kilohertz, just simply using the 500 kilohertz. Now it becomes more interesting if we use the they call dial there, which of course is using here, and there's the second oscillator in there. So if we go back to our 5, that's our 5 meg, which is up here. So if I just zoom in on that, let's go and have a look at that just so you can see it. Quick bit of focusing here. So that's 5. We go drop down to 4.5. There you go. Okay, let's now switch the dial to dial. That now gives us both the 500 kilohertz and the output of this oscillator here. So if we look at the dial at the top, on an 80, it says 80, 70, 30 and 20. With 80, that means it's 0.8, so it should be 0.8. So if I now retune the receiver, you can definitely hear that's the same, and that's on 0.8. So if I now make an attempt to go and have a look at the dial, you can see that's 4.8. We're now adjusted the dial to 4.6 here. So what we'll do now is I will turn the control on the Calibrators Crystal and we'll see if we can actually pick up the 4.6. Now interestingly, because of the way this scale is arranged on here, we're going to have to go back the other way. So 0.6 is that way, so if we move this way, like 6.4, 6.3, 6.2, that's it. It's not bang on, but there we go. So that's reading 4.6 meg off there. Obviously we cut that off, so that's taken away the dial and just leaving us with the 500 kilohertz markers. So that's about all there is you can say about one of these. They work quite well, but I must admit it does it will put me off the fact that there were so many components needing changing to make it work. And it's not that flexible device. It's useful, but there you go. So that is the Calibrators Crystal number 10. Hopefully, when I have a spare minute, I'll do one for the LM13 crystal calibrator and also the BC221. Thanks for watching.